All right, guys. Questions on the homework? Questions on any of the homework assignments? Any of them that you all want to look at or have questions over?
What are we doing Thursday?
Thursday will be a makeup review day. Yep. All right. Questions over the homework? What we're doing today is continuing our section over solving these rational equations. So we're looking at more solving. And again, the first main step in solving these rational equations is making sure that the denominators are all factored before we do anything else, because we need to make sure that they are in simplest form before we look for restrictions and multiplying it by the least common denominator. Now the first denominator is x plus 1. The degree is 1. There's no common factors between the x and 1, so that is simplified as it gets. Our other two denominators are the same, and they're actually both just 2x. Those we can say are simplified, mainly because they are a single term. So that tells us our restrictions, the values of x that would cause the denominator to be 0, are going to show up in either x plus 1 or 2x. Now the 2x is kind of nice to solve. We can divide both sides by 2, telling us that the value of x that would make that be 0 is, well, 0. And the x plus 1, we can subtract 1 from both sides, telling us that if x is negative 1, it would cause the denominator to be 0. It's our other restriction. So if 0 or negative 1 shows up as a solution, we will have to remove them from our solution set. Now we can start solving. We need to multiply by the least common denominator, our expression that's going to make the denominator simplify out. What is one of the terms that we have on bottom? 2x. So we can start off by multiplying everything by 2x. Now in the far right left are 3x over x plus 1. Nothing's going to simplify on bottom, top and bottom, by multiplying by the 2x. But our middle rational expression, the 2x and 2x, will simplify. And on the far right, the 2x and 2x will cancel out. So even though the 2x does show up in the denominators, in two different denominators, it only shows up once in each one, so we only need it once. The other term that we're missing is x plus 1. And here the x plus 1 and x plus 1 will cancel. So the least common denominator we needed to multiply everything by was 2x times x plus 1. Now what that leaves us in this first rational expression is 3x times 2x. Well, our 3x times 2x is going to be 6x squared. 3 times 2 is 6. X times x is x squared. Minus 5 times our x plus 1 is equal to 3 times x plus 1. Questions on what we've done so far? So really with those denominators, we can take it one term at a time, multiply it through, see what cancels, and then go from there. We multiplied by the 2x, and 2 of the denominators simplified out, but the third one didn't. We saw that x plus 1, so we multiplied through by x plus 1. It does simplify the last one out, giving us this here. Now at this point, we need to simplify these parentheses. All right, guys, up here. Now our 5 times x, negative 5 times x, is going to be negative 5x. Negative 5 times 1 is going to be negative 5. Is equal to On the other side, we'll distribute the 3. 3 times x is 3x plus 3. Now, since we do have an x squared term, we need to get this equation equal to 0. So what can we do first? We can subtract 3x. We can minus 3x from both sides. Our 6x squared will be the same, but our negative 5x minus 3x, so it'll be negative 8x, minus 5 is equal to 3. What can we do next? Minus 3, because again, we want to get this equation equal to 0. So the only thing left on the one side is the 3. And if we subtract it over, what we end up with is 6x squared minus 8x minus 8 is equal to 0. Questions on this so far? Is there a greatest common factor between 6x squared, 8x, and 8? 2. We can factor it out. And if I factor the 2 out of 6x squared, we get 3x squared. If I factor the 2 out of 8x, we get 4x. And if we factor the 2 out of 4, or 2 out of 8, we get 4. Now, the 2 is not going to be as important to this whole thing, because again, whenever we multiply two things together and equal 0, one of them has to be 0. Well, we're multiplying 2 with this quadratic. Well, the 2 just can't magically become 0. The only part of this that can be 0 is our 3x squared minus 4x minus 4. That's what can be 0. Now, we will need to factor it. Two sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. Factors of 3x squared, well, our x squared will be x and x. The factors of 3, there's only one set, 3 and 1. Where do we want to put the 3? Second one, first one? Okay. We're just going to pick a spot. It doesn't matter where. Because that's the nice thing about checking it. Last thing, 4. Factors of 4. 1 and 4, 2 and 2. And we can check this here. 3x times negative 4 is going to be negative 12x. 1 times x is going to be positive 1x, giving us negative 11x. Is that the middle term we wanted? No. So we can switch the 1 and 4 and try this again. 3x times negative 1 is going to be negative 3x. 4 times x will give us positive 4x, and negative 3x plus 4x gives us a positive 1x. Is that the middle term we wanted? Yes. And no, it's not. So we tried every combination of the 1 and 4. So we'll have to switch it to 2 and 2, and we can try this again. 3x times negative 2 is negative 6x. 2 times x is plus 2x, giving us the negative 4x that we wanted. Now again, if we do get the correct number but wrong sign, so if it gave us positive 4x instead of negative 4x, flip the signs, and it'll fix our sign error. So it gave us the correct middle term, yes? And we're solving for x. We're trying to find out what value of x will make this be 0, yes? These are the correct factors, so we're saying that 3x plus 2 times x minus 2 gives us 0, which means that either 3x plus 2 is 0 or x minus 2 is 0. When we multiply these two together, we get 0. So one of these two has to be 0. X is going to make one of these two be 0. Well, we can start off with the 3x plus 2 by minusing 2 from both sides, telling us that 3x is equal to negative 2. At this point here, we can divide both sides by 3, telling us that x is negative 2/3. On the other side, we can add 2 to both sides, telling us that x is equal to 2. Are either one of these solutions our restrictions? No. So that means that both of these work. Negative 2/3 and negative 2 work. If we wanted to check it, we could plug it back in, and it would give us a true statement. But that's it with these here. Questions on this so far? All right, let's look at the next one. Now again, before we start finding restrictions or multiplying through with our least common denominator, we need to make sure all the denominators are factored as far as they possibly can go. Now the x plus 1, our first denominator, that's as simplified as it gets. There's no greatest common factor. There's nothing we can do to it. However, the x squared minus 1 is factorable. And it's actually a difference of perfect squares. Since the middle term is negative, our signs are going to be opposite. Factors of x squared are x and x. Factors of 1 are 1 and 1, because it's our a squared minus b squared. X times x gives us our x squared. 1 times 1 gives us our 1 squared. So we get x plus 1 times x minus 1. Restrictions. There's only 2 places where the denominator can be 0. That's with x plus 1 and x minus 1. Now the x plus 1, we would subtract 1, telling us that if x is negative 1, we'd have a denominator of 0. With our x minus 1, we add 1 to both sides, telling us that if x is positive 1, one of the denominators would be 0. So as long as we don't get 1 or negative 1 as a solution, we will be good. If we do, we just have to throw that solution out. What is one expression we need to multiply the entire equation by? X plus 1. And in our far left expression, the x plus 1 and x plus 1 will cancel. In the middle, the x plus 1 and x plus 1 will cancel. The 3 does not have a denominator, so nothing's going to simplify with it. It's just going to be 3 times x plus 1 at the moment. Do we have anything left in the denominators that needs to be simplified out? X minus 1, which means we also have to multiply the whole equation by x minus 1. And in the middle expression, the x minus 1 and x minus 1 will cancel. Now what that leaves us with is 4x plus 1 times x minus 1 is equal to 12 plus. Because in the middle term, that 12 is all that's left. The x plus 1 and x plus 1 on top and bottom simplified. X minus 1 and x minus 1 on top and bottom simplified, leaving us with just the 12. Is equal to 3 times x plus 1 times x minus 1. Questions on how we got to this point here? Now we need to do some simplifying. Here we're going to distribute the 4x. 4x times x is 4x squared. 4x times negative 1 is negative 4x. 1 times x would be plus x, and 1 times negative 1 is going to be negative 1. Now we also have to multiply the x plus 1 and x minus 1. Does anybody know what x plus 1 times x minus 1 is going to factor to? x squared minus 1. Now, one of those is knowing how that works, or how those factor, but also we started out with what? X squared minus 1 and factored it to what? X plus 1 times x minus 1, yes? So logic should dictate that x plus 1 times x minus 1 should multiply back together to give us what? X squared minus 1, yes? Because if it factored to give us x plus 1 times x minus 1, it should multiply back together to be x squared minus 1. So what that means is if we do notice that, well, I can just replace it with x squared minus 1. Because we factored x plus 1, x squared minus 1 to be x plus 1 times x minus 1. So they should multiply back together to give us this here. But off to the side, I will show you this here, because we can distribute x times x is x squared. X times negative 1 would be negative x. 1 times x is plus x, and 1 times negative 1 is negative 1. Negative x plus x is indeed 0, telling us that is indeed x squared minus 1. So if we notice that, we can just replace x plus 1 times x minus 1 with the x squared minus 1. Although if we didn't and we multiplied it out, we would still get to the same place. Doing it this way, we get there with one less step. On the left-hand side, we can combine like terms. Negative 4x plus x is negative 3x. Minus 1 is equal to 12 plus. Here we can distribute the 3. 3 times x squared is 3x squared. 3 times negative 1 is negative 3. We have one set of like terms to combine first. 12 minus 3 would give us 9. We have x squared terms, yes? So what can we do first? We need to get this equal to what? 0. What do you all want to move first? Yes. I would combine the square terms first. I'd get them on the same side. Because it's not going to happen here, but on the off chance that we move and get all the x squareds on the same side and they cancel out completely, that means it's going to work out a little nicer. Because if x squared factored out completely, and all we're left is negative 3x minus 1, that means I just need to get the x by itself and solve from there so we can move the numbers over. We don't have to move everything over onto the same side. Does that make sense? Because we don't have x squared, so at this point I can add 1 divided by negative 3. We have our answer. So it's sometimes nice to move the x squareds first to just make sure that they don't cancel out completely. Well, here they don't. So that means our next step is to subtract 9 from both sides. Telling us x squared minus 3x minus 10 is equal to 0. And we can go on and factor it. Third term is negative, so the signs are opposite. One's going to be positive, one's going to be negative. And it really doesn't matter which one we put as positive, which one we put as negative. I just have the habit of putting the first one positive, first one negative. Only factors of x squared, x and x. Factors of our 10 are 1 and 10 or 2 and 5. 2 and 5, which one do you want positive? 2, 5 is negative. Off to the side we can check and make sure. X times negative 5 is negative 5x. 2 times x is plus 2x, giving us negative 3x. Is that the middle term we wanted? Yes. All right. Now we do have two things multiplied together equals 0, so one of these has to be 0. With our x plus 2, we can subtract 2 from both sides, telling us that the solution for this here is that x is equal to negative 2. For x plus 5, or not x plus 5, x minus 5, we're going to add 5 to both sides, telling us x is equal to positive 5. So our two solutions are negative 2 and 5. Are either one of these values one of our restrictions? No. So both of these work. Negative 2 and 5 are our two solutions, and we're done with that there. If we wanted to check, all we've got to do is plug it back in and see, do both sides of the equation give us a true statement? So if I were to check negative 2, it would be 4 times negative 2 plus 1 over negative 2 plus 1 is equal to 12 over negative 2 squared minus 1 plus 3. I think they had you check some of these before. Now again, check them. We're just trying to make sure that the one side is equal to the other. Now at this point here, since it's straight numbers, we can just plug this into the calculator, let it do it for us. So we can just pull the calculator up, find the right page. Oh, there we are. 4 times negative 2 plus 1 over negative 2 plus 1. 7. On the other side, we have 12 over negative 2 squared minus 1 plus 3 is also 7. So that tells us 7 is equal to 7. That is a true statement. Both sides are the same. So negative 2 is a solution. We can do the same thing with 5. 4 times 5 plus 1 over 5 plus 1. Let's see if that equals 12 over 5 squared minus 1 plus 3. And again, at this point, we can pull the calculator up and say 4 times 5 plus 1 over 5 plus 1 is 7/2. Say 12 over 5 squared minus 1 plus 3 is also 7/2. So we're saying that 7/2 is equal to 7/2. So that checks out. That works. Questions on any of this so far? Six. That would make all the difference. Now, 2 of the 3 denominators are simplified already. X plus 3 and x minus 3. Now, x squared minus 9 is not factored completely. And it'd be very tempting to go on and just set each one of these equal to 0 and solve and go from there, and then multiply the whole thing by x squared minus 9, x plus 3, and x minus 3. Will that give you the correct answers? Yes. Will it give you too many answers? Yes. And it's because x squared minus 9 will factor. X squared minus 9 is a difference of perfect squares. Well, we'd have x and x, 3 and 3, and our signs would be plus and minus. So x squared minus 9 does factor to x plus 3 times x minus 3. And if we did, we'll look at the restrictions here in a minute. If I did multiply everything by x plus 3, x minus 3, and x squared minus 9, well, the x squared minus 9 is what? X plus 3 and x minus 3, which means we're actually multiplying everything by an extra factor of x plus 3 and x minus 3. Because if we did this here, and simplified, because this will simplify here in a minute, the x minus 3 and x minus 3 here would cancel. Here the x plus 3 and x minus 3 would cancel with our x plus 3 and x minus 3, and our x plus 3 would cancel. But we still have that x squared minus 9 across all three, which means it's going to make this equation bigger than it needs to be. So that's part of the reason why we want to make sure each of these terms is factored as far as possible, so that if there is a term that's shared or something that's in common, we don't repeat it more than it's necessary. Here we only needed x plus 3 and x minus 3 once. Adding that x squared minus 9 is actually adding both of them an additional time. Restrictions. Let's look at the restrictions before we go further. Yes. All right. X plus 3 and x minus 3 cannot be 0. Any value of x that would make either one of those be 0 is going to be a restriction. Well, really it's saying that x cannot be positive or negative 3. Because if it's positive 3, x minus 3 would be 0. If it's negative 3, x minus or x plus 3 would be 0. It is 133. So we multiplied through by the x plus 3 and x minus 3. We get this here, 6 times x plus 3 is equal to 8x squared minus 4x times x minus 3. Questions on how we got to this here? Question?
No, I just thought we were trying to along.
Yeah, we're problem 3.
I was kind of in disbelief.
And it's not so much that the problems themselves take a while, because once you all start doing them, and I'm not explaining through step by step, they actually go faster. Let's distribute. Here we can distribute the 6. 6 times x is 6x. 6 times 3 is 18. We still have the 8x squared. Negative 4x times x is going to be negative 4x squared. Negative 4x times negative 3 is going to be plus 12x. Now on the left-hand side, the 6x and 18 do not have any common factors. But 8x squared minus 4x squared will simplify to 4x squared plus 12x. We have an x squared term, so we do need to get this equation equal to 0. Personally, I try to move all the terms over so that the x squared term is positive. So what we can do first is subtract 6x from both sides, telling us that 18 is equal to 4x squared plus 6x. And lastly, subtract 18 from both sides, telling us 0 is equal to 4x squared plus 6x minus 18. Four x squared, 6x, and 18 has the greatest common factor of 2. Yeah. 2. We can factor the 2 out of 4x squared and get 2x squared. We factor the 2 out of 6x, we get 3x. And when we factor the 2 out of 18, we get 9. Since the third term is negative, our signs are again opposite. Factors of 2x squared, well, we'd have x and x. 2 and 1. Do we want to put the 2 in with the first x or the second x? The first x. Factors of 9 are 1 and 9 or 3 and 3. Which one do we want to try first? 3 and 3. We'll go with 3 and 3. And check this here. And if we check this here, 2x times negative 3 would be negative 6x. 3 times x is plus 3x, giving us a negative 3x. Now that is the correct number, but wrong sign. So we need to flip the signs. Because when we flip it, now 2x times positive 3 would give us positive 6x. Negative 3 times x will give us negative 3x. So it switched to the sign from negative to positive. And what that tells us is that 2x minus 3 is equal to 0, and x plus 3 is 0. As we do have two or more things multiplied together to equal 0, so one of them has to be 0. So with the 2x minus 3, we can add 3 to both sides, telling us that 2x is equal to 3. Divide both sides by 2, telling us x is positive 3/2. For x plus 3, we can subtract 3 from both sides, telling us x is negative 3. Questions on how we found our two solutions? Is one of these a restriction? Yes. Because we said x could not be positive or negative 3. So x equals negative 3 is a restriction. We remove it, we cross it out. That solution doesn't work. It's an extraneous solution. It's a solution that we get from solving, but does not work in the original context. So we throw that solution out. Questions on this here? We're going to do one more, and then we're done for the day, and we will finish this note sheet tomorrow. The nice part is once y'all start doing them on your own, and there's not the explanation side to them, they don't take as long to do, because you're not having to wait for me to pause, catch up, go through and explain side details. Now looking at this here, the first thing we need to do is factor. X squared minus 9. X plus 3 and x minus 3. X squared minus 6x plus 9 factors. X minus 3 and x minus 3. And these factor kind of nicely because, well, all the denominators have one of two things. Either x plus 3 or x minus 3. Either x plus 3 or x minus 3. Now, even though it does show up more than once in the different places, we're really saying that x plus 3 cannot be 0 and x minus 3 cannot be 0. With x plus 3, if x is negative 3, that's going to be 0 because negative 3 plus 3 is 0. With our x minus 3, x cannot be positive 3 because 3 minus 3 is again 0. All right. We need to see what our least common denominator, what we need to multiply the whole thing through by. What's one of the factors we can use? X plus 3. Let's start with it. If we multiply the whole thing through by x plus 3, incidentally, in the far left one, the x plus 3 and x plus 3 will cancel. In the middle, nothing will simplify. But in the far right side, rational expression, the x plus 3 and x plus 3 will cancel. What can we multiply through next? X minus 3. We can look on the ends first. On the far right, The denominator is simplified out, so the x minus 3 won't cancel with anything. On the far left, the x minus 3 and x minus 3 will cancel. In the middle, our x minus 3 we multiplied it with will cancel with n x minus 3. But in the middle, how many x minus 3's did we multiply it with? We did 1, yes, so far? So it only will cancel with 1. But we still have one more on bottom, yes? Which means we have to multiply it a second time to get that other one to cancel. So that means we're having to multiply all of them by x minus 3 twice, because that x minus 3 did show up in one of the denominators twice. If it shows up twice, we need it twice. So let's see what that leaves us with. We have 4x times x minus 3 is equal to x minus 1 times x plus 3 times 2 times x minus 3 times x minus 3. Now at this point here, we're going to distribute. 4x times x is going to be 4x squared. 4x times negative 3 is negative 12x. Is equal to. Our middle one, we can go on and multiply through. X times x is x squared. X times 3 is 3x. Negative 1 times x is negative x. And negative 1 times negative 1 times 3 is going to be negative 3. Plus 2 times. Here we can multiply through, or there's an easy way we can do x minus 3 times x minus 3. It's actually going to be x squared minus 6x plus 9. We got it from above. But if we didn't see it, we can still multiply through. Because our x times x would give us x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And lastly, negative 3 times negative 3 is positive 9. Let's combine like terms. Well, 4x squared minus 12 is just going to stay that way. On the other side, we have x squared. 3x minus x is going to be positive 2x. Inside the parentheses, negative 3x minus 3x is going to be negative 6x. Now we do have to distribute that 2. 2 times x squared is going to be plus 2x squared. 2 times negative 6 is negative 12x. And lastly, 2 times 9 is 18. Finally, our last combining like terms, x squared plus 2x squared is 3x squared. 2x minus 12x is negative 10x. And negative 3 plus 18 is going to be plus 15. So it took us a while there to get the like term, simplify each side down. Now we just need to get this equation equal to 0. So the first thing we can do is what? Minus 4x squared from both sides. Now I try to keep the x squared positive, but here it's going to take less moves to move the 4x squared and negative 12x over to the other side than it is to move the 3x squared minus 10x plus 15 to the other. So we end up with negative x squared plus 2x plus 15. Now to factor this, to make this nicer, I'm going to factor the negative out. I want to pull that negative out because I want that first term, that x squared term, to be positive, because it's going to make things nicer if that term is positive. Now, since our third term is negative, our signs are going to be opposite, positive and negative. Only factors of x squared are x and x. And the factors of 15 are 1 and 15, or 3 and 5. And for this here, we're going to want x plus 3 and x minus 3 to get that negative 2x middle term. And if we do check this here, x times negative 5 would be negative 5x. 3 times x would be plus 3x, which does indeed give us the negative 2x. All right, guys. Almost done. We have x plus 3 and x minus 5. We can set both of these equal to 0 and solve. So here, if we subtract 3 from both sides, we get that x is equal to negative 3. X minus 5, we can add 5 to both sides, telling us that x is equal to 5. So here are two solutions of negative 3 and 5. Before we could say that's done, is either one of these a restriction? The negative 3. So the only actual solution that we have for this is x is equal to 5. And that's it.